Uh, okay, let's see if my stream gets taken down for playing this in the background. Alright. So, I have the mic here. It's a bit awkward, microphone, because I usually have it set up in a nicer place. It just doesn't like me today. It just doesn't like me today. Okay, let me bring it closer. Okay, let me bring it closer. Okay, let me bring it closer. Okay, so it's working, which is good, maybe. I think everything's working. I think it's live, maybe. Maybe. All right, let's. So, well, we have that one working. That's a little bit. I think that's a bit. I don't want it to be too loud. So, okay, there you go. This is definitely getting copyrighted. Anyway, I just started this one, right? So I'll be trying to run this as frequently as possible. Hopefully I don't get absolutely cooked by my internet company, but we'll see how it goes. This is just a test to see what happens here. However, right, we are going to be doing. Hey yo, what is up, Jimbo Hayes hasn't 21. Okay, wait, is my stream on a fucking delay? No, it's because I'm just hella behind. That's why. Okay. Yeah, what is up, my boy Jimbo? Hey, how's it going, mate? So we're gonna be looking at this Heffernan exam from 2017. It's a pretty old exam, let's be honest. F 2017. Damn. Yeah, I gotta save all the. Is this a tough exam? I'm not for well this bottom question down here, because I had a little read through with one of my students. This bottom question down here is a pretty interesting one. So question D, part C. I think this whole question 9 is kind of cooked, but it's the thing is it's very straightforward if you look at it correctly. So like here, if you look at this first part's pretty straightforward. Find the stationary points. Now the annoying part is that this is actually in the new study design would say in terms of A, right? So you'd have that to help you out a little bit. But what you can do is you can just do f dash of x equals 3x squared take 2ax, right? Is my audio fine for everyone in the stream? I'm just checking. And then we can do f dash of x equals 0, which means 0 equals 3x squared take 2ax, right? Yeah, it's good. Okay, that's sure. So then you can you get the solution here that x either equals 0 or 2a over 3, yeah, from just solving this quadratic. Does anyone want me to explain that one? Explain that part? Or is that pretty straightforward? That's like quadratics 101 right there. Yeah. And the big thing here is that it wants me to get a coordinate. Uh, how did you get that so quickly? So, I mean, the thing is, a lot of the work that I do, like a lot of the things that you do to speed yourself up is there's those little mental tricks that you have during your like when you do maths to get better at it. So here, if I just like here, I'm factorizing out the x squared, I get this, yeah. And like I because I've done this, I've done questions like this about 100 times. I'm able to realize that the solution is either x equals 0 or well, what's it called, 0 equals 3x over 2a, which means that x equals 2a over 3. So this one is purely just the pure like this form, it comes up a shit ton. So like if you get used to seeing this, you're able to just like do it really quickly. It's like I'm gonna say it's hard to see those things immediately, but the thing is, you want to try and look for tricks. Like one thing you want to do when you're doing maths, you want to try and be as lazy as possible. Yeah, like I do not recommend people, sweating their hearts out on these sorts of questions. Like especially showing this much working out. Yeah, if you can do it faster, the methods examiners would like it faster. If you can do it more elegantly, they're gonna like that as well. Yeah. My old teacher used to be an examiner, and she used to tell me they don't care. Like, sure, they care a little bit. Like, they'll pick you up on notation and that sort of thing, but they're not gonna give they're not gonna give that much of a crazy they're not gonna give that crazy amount of a shit to you messing around. Yeah, like sure, I can realistically jump from this line down to these two lines down here without them caring too much. Now, the big thing where people get stuffed up is where they miss this coordinate part, right? So then you say f dash of 0 equals, well, 0 in this case, because here if we plug 0 into both of these, we get 0. And then here we get f dash of, oh wait, no, not f dash, my bad. It's just f, yeah? We get f of 2a over 3, which means here we get 2a over 3 cubed, take away a 2a over 3 squared, yeah? Now this part people find very hard to evaluate, right? But we'll use some simple tricks here. So here we're just going to expand this out using index law. So 8x cubed over 27 take away, right? We get here so we have 8x squared over 27. Over here we'll get 4a cubed over 9, yeah? Get 4a cubed over 9 here, right? And someone's calling me. Wait, give me a second. Just give me. My bad, gang. My bad. One of my friends accidentally called me and was like, damn, where's everyone at? Because they're like, I'm currently in university right now. And they're like, damn, where's everyone at? So, like, type shit. Anyway, so this question is not too bad. I did the final bit. I did the final bit of working out when I was muted. But, oh my god, bro. Why does this stylus seem to work? Oh, stop it. There you go. So, the big thing that people forget is that they forget to give the answer as a coordinate, right? So they forget to give the answer as a coordinate, and then they're like, "Oh shit, I got the right answer. Here's the first answer. Here's the second answer." No, those aren't right. They're not right, right? They want a coordinate, which means they want a coordinate pair, right? F of 0 is pretty easy to find out, but it's this one that people struggle a lot on, right? And it's more or less like, the algebra behind it, right? Just remember, always control yourself. The algebra in methods is never going to be like crazy difficult. I'll say that now, yeah? Like sure, there's going to be some difficult questions, but if you stay calm and just follow the simple algebraic rules, you'll be fine. So here, right, I want to say this now. So many people that I teach just forget about index rules. So 1 mark for finding the x values, 1 mark for substituting, and 1 mark for the final answer. I would say, yeah, I would say that'd be a good like understanding of whether of this question. I would actually say, it's 1 mark for finding the derivative of the function, 1 mark for finding the x values, and then 1 mark for the coordinate pairs. Yeah, this I don't think would be a mark, because a lot of people would actually be able to do it. Like, because the thing is, one thing that I find very interesting when I tell people this is that methods is actually really easy, and it's so easy that the examiners won't give you marks for this, because the thing is, it's easy in terms of what they think is easy. Yeah, and these guys have been studying math for, like, I don't know, the past century. Like, they've been doing it long before time had a name. Yeah, so you gotta like put in the perspective of them. They can probably do this calculation in 2 seconds. Yeah, so if you want to push for the higher marks, right, you're also gonna have to learn how to do the calculation in like a few seconds. And one way you can do that is through exposure. I love exposure. I love the exposure that people can do with maths. Because I remember I had one student. She tried to use cue cards. Um, I told her to stop. She didn't listen to me. I just let her do what she wanted to do, and she ended up the way she did. I think she got into the course she wanted to. I'm not exactly sure. She wanted to get in medicine. But medicine is very, very difficult to get into. So I have no idea where she went to. She she just stopped tutoring with me after a while. It's very interesting, to say the least. The cue card method, and after me telling her to not do that, then she went about doing it. But anyways, that's besides the point, right? So, uh, this calculation, it's relatively straightforward, I'd like to say. Yeah. Now this is the part where people tend to get screwed over, right? Because the thing is, it's 1 mark, right? And it says here, find the values of n, right? Where n is a real number for which the equation f of x equals n has 2 solutions. Yeah? Cue cards for maths is crazy. That's what I thought. But, to each their own. So, here, right, when we're thinking about solutions, right? Let's just say we have, like, here, the line y equals n. Yeah? If I like scan this line, like, if you can see here, this one has 1 solution. Yeah? This line has 1 solution. This line has 1 solution. This line has 1 solution. And then I go to this line here. Yeah? Do you see how this has 2 solutions? And when we talk about solutions, we're referring to having 2 intercepts. Yeah? So we have 1 intercept right here, 1 intercept over here. Yeah? So 1 intercept at the 0, 0, and 1 intercept at a, 0. Yeah? Now, when we have those 2 intercepts there, right, we can see that at this y value, right, we're going to have 2 solutions. So here, the solution for this first one is going to be n equals 0. But wait, it says values here, yeah? Now, whenever they use the word values, there's a tendency to have multiple solutions, right? If they think it's only one value, they'll say value slash, in brackets, values, yeah? So you want to be very mindful of that. And the other way, and then to find the other solution, you continue doing the scanning. If you see here, if I draw this line, I have 3 solutions there, yeah? I can visually see the 3 solutions, 1, 2, and 3, right? But if I go a little bit lower, I get 2 solutions again. I hit this turning point, and I hit this intercept value here. So from there, what I can take it as, or I can see that at this y value, when in this case, n equals negative 4a squared over 27, I also get a solution. Now, like, what was the technique that I actually used to do this? Yeah, what was the thing that I used? And I think one thing that people don't value enough of in methods is more or less the geometric intuition of like actually being able to have the graph in front of you. Because if, let's just say, I try to do this question and I didn't have this graph in front of me, it would have been very hard, right? But because I have this graph in front of me, I can literally look at, well, where does the line y equals n? Like, let's just say y equals 1, yeah? Right? That's what this line looks like. Let's just say y equals a half, right? That's what this line looks like, yeah? See how that visual intuition, it helps so much. And you'll find that what I tend to use is how would you do without a graph? So here's an interesting part. When it comes to methods, there's two different ways you can generally do questions. There's the algebraic way, and there's a geometric way. And for these sorts of questions, these solution questions require more or less understanding the properties of the function. Yeah. So you either need to understand the properties of the function, right, to be able to do it. So here, right, because I see that the properties of the function has two turning points, like I can get the shape of it from there, and then I can get the answer, right? But realistically, the only way to go about doing this question is to sketch it out, unless you have an amazing visual intuition in your head, right? But the thing is, the sketch for this graph, especially if you know your polynomials, this sketch doesn't take that long, yeah? And the thing is, this question will come up again and again and again and again, yeah? So I would recommend, right, you don't just want to think about things algebraically, yeah? I encourage you to think about things geometrically as well. And when I say geometrically, I mean like literally sketching out the graph, yeah? And sketching out, well, where does it have these solutions? Because so in the 2025 exam, right, you could only get this question right if you could give a rough sketch of what the graph would have looked like, yeah? The 2025 exam had this. So I'll tell you this now. It's not just like even though this is a 2017 exam, this is an exam not when I did year 12. Okay, I'm not that old, yeah, but this is a relatively old exam, but the same idea still applies. And the thing is, right, this is a brilliant way of showing off that you can get that visual intuition out of it. So does that make sense? Does that any questions about that? Any comments, any concerns about that at all? Because if there's not, I'm going to move down to this bottom one here, right? Which also is very interesting. Yeah, that was all good. No problem, bro. No problem. Because, again, this question, it will come up again, right? Solution questions will come up, and being able to sketch is just a wonderful ability you can have. I think I've seen, like, one type of these solution questions which sort of defies the norm of sketching. And the thing is, if you had a calculator, because you had the calculator with you in that exam, you would have been fine, because you could have, like, you realistically could have been able to guess and check that, yeah? Now, obviously, you don't want to, and eventually, because I intend on doing this for longer and longer, I hope to get to that question eventually. So, one thing that I want to go through is this question here, and it says here, a tangent line is drawn from the graph f at the point u, yeah? So, we know it's drawn from the point u. No other tangent to the graph has the same gradient as this tangent. Find u. So, there's two ways you can think about it. You can either know that this is going to be here, right? Or we can literally just look at the derivative graph. So let's like here, I know what f dash of x is. I know f dash of x is going to be 3x squared take away 2ax, yeah? This graph looks something like this, yeah? And we can see that here, at this point, right, there's only going to be one solution, yeah? That means this is going to be the only tangent with this gradient, yeah? We can find out what that is, right? By simply just trying to find out what the turning point of this graph is. And we can find out the turning point by, again, finding the double derivative. So if we find the double derivative of this graph, right? So it's going to be 6x take away 2a. We realize that f double dash of x equals 0 is another way of describing the turning point. And we get 0 equals 6x take away 2a, which means that x equals a over 3, right? Which means here u equals a over 3, right? And you see, again, right, this little visual intuition of looking at the gradient and seeing when the gradient curve, when there's only one gradient with this gradient, right, one tangent with this gradient, it made this question really easy, yeah? So I think this is, well, from what I've seen, in my perspective, what I've seen is that the thing that differentiates these, like, you know, like these 45 to 50 kids from like everyone below them is because they have this very niche ability to visualize, and I don't think it's appreciated enough by teachers. Because the thing is, it's very easy to teach, let's just say, it's very easy to teach algebraic methods. Like, it's very easy to tell someone that the derivative of the point, well, when the derivative equals 0, we're going to get a stationary point. It's very easy to teach. That's a formula. But it's very, very hard to teach someone to open their mind to the possibility of, well, let's try and sketch the graph to figure out, well, what the hell this is talking about, to try and analyze the information that we're given here. Yeah? So, again, I encourage you to do the same thing. Because the thing is, the question, like, again, if the 2025 exam is any indicator of what the 2026 one is going to look like, and if the 2024 exam and the 2023 exam also are going to be indicators of what this exam looks like, it's one going to be heavily based on algebra, yeah? So it's going to be heavily algebra like intense, where this looks like a piece of cake. And it's also going to be heavily intense in, well, do you actually know what the hell you're doing with the maths? Is there any point of the maths, you know? So yeah, does that make sense? Do you have any questions about that? Any comments? Because this one's a very interesting one. This one's very abstract, right? And here we see that. So we'll see here the graph v. We see v of v comma v. F of v and w comma f of w also lies on the graph f where v is not equal to w. The tangent to the graph of f at the point v and w have the same gradient. So they have the same gradient. Find v plus w. So let's find out. Well, here we have it, f of, we'll find out what f of v is. Yeah, so f of v is going to be equal to, if we look at our tangent equation up here, it's going to be equal to 3b squared take 2av. Yeah, let's find out what f of w is. F of w is just going to be 3w squared take 2aw. Yeah, and we know they're equal to each other. So because they're the same gradient, that means these gradients are actually equal to one another. So we get here 3v squared take 2av take equals 3w squared take 2av. Now, when I initially looked at this question, I had no idea what to do here. Yeah? Oh, wait, w. I had no idea what to do. And I was looking at it for a while, and I was thinking to myself, oh, how can I get v plus w? Because there's no way for me to be able to simultaneously solve this. I only have one piece of information, yeah? I mean, I guess I can use this piece of information here, but the thing is, I can't really form an equation out of it or anything. So, now that we have that idea in our mind, right, that I can't really form an equation out of it, I decided to just try and rearrange it for v and w. So we get here 3v squared. Well, the thing I tried to do is I tried to take all the a's to one side and all the other numbers to the other side. So here I did, 3v squared take 3w equals 2av take 2aw. And one thing I was able to do here was I was able to pull out the 2a, yeah? So I get v take away w. Over here, I'm able to pull out a 3, so I get v squared take away w squared, yeah? And now this is the point where it looks actually pretty familiar, where I get 3v take away w, v plus w equals 2a v take away w. And because we know v is not equal to w, that means v take w is not equal to 0, so we can actually cancel these two out with one another, yeah? And we can see that v plus w equals 2 over 3. Now with this question, yeah, how was I able to notice this step? Or how was I able to even think about this, yeah? And how I was able to think about this is more or less, well, we want to find out V and W, and it can't be in terms of V and W. We can't write an equation for something in terms of itself, right? That's a bit redundant. So the whole idea is I want to try and isolate the A. I want to bring the A by itself, and I want to try and get the A by itself in some way. So that's why I put all the A's in one side, yeah? Now over here, how did I notice to factorize it afterwards? Well, I factorized it because when we factorize, it's a general way of trying to simplify. Now, unless the question doesn't, like here, the question required me to do it, yeah? And it was literally my last option. I wouldn't have factorized unless I absolutely needed to. If I didn't need to, I wouldn't have wasted time factorizing. Because you waste time factorizing, you'll lose like what? You lose like what? 2 to 3 minutes on a 60-minute exam. If you think about it, 3 minutes of a 60-minute exam, that's 1/20th. You lose a decent amount of time, yeah? You're losing almost 5% of that exam, wasting your time factorizing. So here, you sort of want to be able to give yourself a priority order on what techniques you can use and what things you can use to simplify with. So here, in this case, well, I can't really do anything else, So I just factorized it, yeah? Because that was the most logical thing for me to do. And when I factorized it, I saw, well, I got V take away W over here. I got V take away W over here. And they cancel each other out. I can find V plus W. So, does that make sense? Because this, I think, is a very interesting question. And if you want to practice more questions similar to this, I would go and look at... That was really smart, bro. Thanks. I really appreciate you. You don't call me smart, man. I'm not that genius, but I'm in med school. These guys, they got 99s. They got their 99.65s, the 99.9, right? I got like a really good ATAR. I'll say that now. I got a good ATAR, but nothing compared to these guys, bro. I feel like a fucking dumbass. But here, the whole idea that I want to share to you is more or less how powerful doing these back questions on the exams. If you were running out of time for your, like, before your exam or before a test, right, and you want to get better at methods, spec, or actually probably more methods than spec, yeah, for methods specifically, I would go and I would pull out maybe, the 2012, 2013, 2014 exams and try and do the back question, right? And the reason being is because these back questions, they're designed to be the hardest question on the exam, right? They're not designed to be easy. If the whole point is that these questions are sort of the separated question. They have all these other ones up here, but the thing is, these are very formulaic. Like here, you see this one over here. This one is actually a very stock standard question. This as well, e to the x, is a very stock standard question, right? I can see all of this stuff over here, right? Area calculations, average value calculations, they're very stock standard. Does the 2012 study design... Now, that's the interesting part. I'll pull it up. The only difference that should exist between the 2012 VC methods and the current study design should be, like, the 2012 exams used to have modulus functions, as well as, I'm trying to remember it now, it used to have matrices. Now, the thing is, matrices is still relevant in the sense of, instead of writing it using this matrix notation that we used to for this, right? So this is what they used to do, yeah, for transformations. Now, in the current study design, they write it as this. Oh wait, no. Let me just rewrite this one out. Wait, I'm getting a cold again. Bro, why do I keep getting cold? Wait, give me a second. So, the thing is, they rewrite it now like this, yeah, in the current study design. So this is how they choose to rewrite this question. Uh, so the thing is, it's sure the study design is different, but the unique part about methods is that even if it's different, right, it's actually relatively the same. Yeah, like the thing is, like it will look slightly different, and I don't encourage you to do those questions because I want you to train that. I want you to have that as your idea of the current study design. Am I muted? I'm just gonna check if I'm just gonna check if I'm muted or not. I don't want you to use those exams because I want those. I don't want you to think that those are the exams where you think this is where my exam knowledge is going to come from. It's going to come from 2012. No, you should use the 2025, 2026, 2025, 2024, 2023 as your baseline of what a VCE exam should look like. But I think that the 2012 exams and these older exams still provide a lot of valuable questions that you can do. So I'll pull it up. I think the best one that I can think of is the 2014 one. Now my internet's being a bit slow, which is great. Let me have a look at this. Let me just have a look at this one here. So, yes. So, we'll have a look at the back question here. Yeah, right. This is a VCAR exam, and despite the fact it's from 2012, I'll tell you what isn't relevant to the current state design out of this whole exam. Yeah. These are the stock standard derivative questions. I would expect all of these ones to be on here. I'd expect all of these ones to be on here. This wouldn't be on there. This wouldn't be on there. And I would say you're still able to do these two, even if you can't do the graph. If I keep looking down, the rest of these questions are still relevant to the current study design. That's the interesting part. So let's have a look at this one. Here, it says let f of x be this function. This is its domain. I always tell people if they're going to stuff you over in an exam, it's going to be the domain. So I'm screen sharing. Am I screen sharing the right thing? That's not. I just need to check this really quick. Check this really quick. So I am screen sharing this correctly. So I'm looking at this question here. It says it find in terms of n the stationary point. So let's differentiate this one, right? We have f dash of x, right, equals here, it's negative m e to the negative mx plus 3. Which means we have here f dash of x equals 0. Right? So find in terms of m the coordinate of the stationary point. So that means I can say here that 3 equals negative m. Oh, wait. 0 equals negative m e to the negative mx plus 3. And if I rearrange this one, I have negative 3 equals negative m e to the negative mx. And here I have here e to the negative mx over 3m, right? And over here, I get negative mx equals ln of 3 over m. And I get here x equals negative 1 over m ln of 3m. Yeah? And you see how that question, it's still possible in the current study design. This question, just because it's old, it doesn't mean it's not a valuable question. Now, I don't want you to get this confused by saying this is the question you should do, and this should be the thing you should study for. Yeah? This isn't the exam you're studying for. You're not studying for an exam in 2012. You're studying for an exam in 2026. Yeah? That's 14 years earlier. That's 14 years later. Things will have changed. But I think using these past exams is still a great way of being able to train yourself in a variety of questions, even if some of them aren't related, right? And the beautiful part is that it's very easy to go to them and to look through them and to see, well, what might be relevant, what isn't. And if you can't find that, well, I've got a website dedicated to all of these sorts of things. I'll pop it in the chat. But I have broken all of these past exam questions here to be relevant to the current state of design. And they're completely for free. I don't charge anything for this. I don't want to charge anything for this because they're already free on the VCAR website. I'd be a pretty big scumbag if I was charging for this. Right? And I want you to have a look at these questions and to say to yourself, well, you know, these things are all relevant to the current study design. Now, there are some matrices things in there. Sick, bro. This is cool, lad. No problem, man. And so I've broken it up. Now, I will say the quality varies between some of these. The circular functions one and the integration one were the first two I made. Yeah? All the others came afterwards. Now, I'm planning on updating these two to be a little bit more useful. One thing I did do, though, was in things like the transformation sections, I have kept some matrices components to them. Yeah? And the reason behind that is because I still think, I personally believe that matrices is still somewhat part of the study design. It's just that it's not explicitly part of the study design. So again, when I say this, they're just rewriting a matrix equation which used to look like this. xy plus bd into the form that looks a little bit more like this. That's what they're doing. And I can pull up the textbook chapter for you. And you might be saying, well, the textbook isn't that useful. I disagree with you. Again, I think the textbook provides, again, a more... It's not the thing you should be studying for. Yeah, you're not studying for a textbooks exam. You're studying for an exam made by BC, by VCAR, right? But I still think those questions are valuable to give you like insight and surrounding on, you know, what you could expect, right? I think people are too quick to throw away textbook questions. And I think the reason is because they're very hard. And because they're very hard, right, they're like, oh, what's the point of this? It doesn't relate directly to the exam. Well, obviously nothing's going to relate to your exam unless it's the exam. That's how exams work. But the idea is to more or less broaden your horizons beyond that. And to see that it's not just that, oh, well, this is relevant for the exam. You don't know what's going to be on the exam this year. But to give yourself a large enough scope to be able to approach these exams, I think is the thing that you should try and do. Yeah? And again, I encourage that by looking at past exams, looking at past questions, you know, getting resources from people, talking to your teachers about what might be useful questions to do. So that's just my take behind it. And I'll continue demonstrating this video. It says here, state the values of m such that the x-coordinate is a positive number. Yeah? So the x-coordinate of the stationary point is a positive number. So we know that the x-coordinate of the stationary point is going to be this. This is the x-coordinate. I'm going to rewrite this one. ln of m over 3. Yeah? Now, this graph, right? M must be greater than 0 here. I can see that. The log can't be less than 0. And what will this graph look like? It's going to look like this. It's going to be 1 over m. Yeah? This is always positive. Yeah? Which means here, we look at this graph, we look at this part, and we have a sketch of this one. This one here is going to look like this. So why am I drawing these? It's to tell you that this part of the graph actually doesn't matter, right? It's the 1 over m part won't make it being positive or negative. It's always going to be positive, yeah? So now we have to look at this one. Well, here, the only way for a positive number multiplied by a positive number, or well, to get a positive number from a positive number through multiplication is by multiplying by a positive number. So here, it means that this ln of m over 3, right? ln of m over 3 must be greater than 0. Because when it's greater than 0, we can see that here, the output is going to be positive. Yeah? So we have a positive number times a positive number. We get a positive value, which is what we want. So we rearrange this. We get m over 3 equals 1. Yeah? And we get m equals 3. So, here, again, I'm visualizing it. Like, you might say this is an old exam skill. You don't know, they don't visualize it anymore. Yeah? They don't do these sorts of things. They do. They did in the 2025 exam. They did it in the 2024 exam. But they did it in a slightly different way in the 2024 exam. But to be able to, again, have that scope and be able to see that, you know, just because a question's old doesn't mean it's bad. Yeah? It's still probably equally as valuable as any other question that you're doing. So, any questions about that? And I would say this question is probably the most unknown formula known to man. Yeah? Again, let's visualize what this looks like. For a particular value of m, the tangent to the graph of y equals f of x at x equals 6, x equals negative 6, passes through the origin. Let's have a look at this graph. Yeah? It doesn't really matter how I draw this graph. Yeah? I'm gonna draw this graph. It's gonna look something like this. Yeah? Yeah? It doesn't really matter. What matters though is that here, this is my value at x equals negative 6. If I draw the tangent here, I can see it's passing through the origin. So I see 2 points it passes through. But I also know that here, that means I can use y2 take y1 over x2 take x1 to find the gradient of this. I can also use the formula f dash of negative 6 to find the gradient of this graph. So I can say here, f dash of negative 6 equals y2 take y1 over x2 take x1. Yeah? I know what... Dude, why do I keep getting messaged by a bunch of people? Holy shit, why am I Mr. Popular whenever I get to this stuff? Yeah, I always become Mr. Popular whenever I'm doing something, man. I swear. Anyway. So we get here f dash of negative 6 equals y2 take y1. I know this point. This point is just negative 6, comma, f of negative 6. Yeah? This point here is 0, comma 0. So here we have f of negative 6 take 0 over negative 6 take away 0 equals f dash of negative 6. Which means here, I get f... Oh wait, if I plug in what f of x is, yeah? F of x is up here. I get here e to the 6m take 18 over negative 6 equals, it will equal the derivative. So it's going to be negative m e to the 6m plus 3. I'm looking at the question above because that's where I found the derivative of the function. So then here, right, if I do this question, it becomes 6m e to the 6m take 18 equals e to the 6m take 18. These cancel out. I can just solve this by, again, I bring them all to one side. Wait, what's 6? Yeah, here 0 equals, and then I factorize out 6m. So I get here 6m take away 1. And then what I'll see here... Oh, where did I get the... Where did I get the 6 from? Oh, that's why I got 6 from. That's why I got it's okay. My bad. So that means here, I see that e to the 6m either equals 0, or 0 equals 6m take away 1. Which means that m equals 1 over 6, or no solutions here. Right? Why does this have no solutions? If I try and sketch the graph, e to the 6m, it's going to look like this. Yeah? But this is y, and this is e to the 6m. This is the m axis. Does that make sense? So I get this answer here. Any questions about that? So, again, I don't, like, here, I'm doing a lot of problem solving for these questions. And you're going to say to yourself, well, Thiessen, I don't have the time to do that in my exam. You don't. So what am I going to encourage you to do? I'm going to encourage you to see a lot more of these questions. To see a lot more, you do a lot more. Again, past exams, textbook questions, trial exams. I have this happen in paper, yeah? I got this happen in paper by searching up 3 VCE resources. I'm not obviously allowed to post a link for that, because if I do, I'll get in trouble for it. But who's calling me? What? Dude, I swear. Bro, I swear, I got another call again. Do you think it's essential to be able to visualize graphs in your head? You don't need to. You have a pen and paper. I don't like people get the idea that they have to visualize graphs. I've drawn most of this stuff. Yeah? Like, I haven't done this in my head. It's a nice skill. I would say it's a very nice skill to have. But I don't think you need to have that skill. Yeah? I definitely didn't have that skill. Yeah? And I finished year 12 with a 99.05. Right? So I would like to consider the fact that I did pretty good. Yeah? And I want to say to you that if you can't visualize in your head, because some people just physically can't visualize in their head. Like, imagine I told you to visualize these two graphs in your head. Like, you know, some people just physically can't do that, which is fine. You don't need to be able to visualize them in your head. Yeah? What you need to be able to do is you need to be able to sketch them on a piece of paper. If I give you 4x, I should know it looks like this. Yeah? If I have a g of x, I can have it like this. I think it's one of the most undervalued skills that we have in methods, because people are so concentrated on, you know, let's just say teaching integration, you know, teaching differentiation, teaching those things. But those are all processes. Processes are very easy to do. Problem solving is where the skills are, yeah? And we build problem solving by being able to actually visualize what the situation is. So that's just my belief behind it. You know, there could be other tutors that are saying to you, you know, you need to be able to visualize 16 different graphs in your head. I'm just like, that's completely unrealistic. I can't do that. They can't do that. If your tutor tells you to do that, they're full of shit. Because I've been like, I'll tell you this now. I've done vector calculus that looks like this. Yeah. I've done vector calculus that looks like this. There was no universe where I'm visualizing that in my head, yeah? Like most, when you get to a university level, you'll see that, obviously, vector calculus isn't part of special methods, yeah? It's something that I've done. But you'll see that you won't need any of that, yeah? They're not going to give you anything crazy, yeah? They're still going to be realistic, right? Of what you can draw. You should be able to draw everything by hand, yeah? Again, very underutilized skill, graphing. That's just my personal opinion behind it. Because I feel like a graph can show a lot about a function, yeah? So, you know, take that as you may. Do you, any other questions about this? If I pull up, let me just pull this one up while I'm yammering on about something. No, this one I'd say is pretty... I won't bring this one up because this one uses a skill that you won't learn until you do integration. And I don't think integration skills are they're not necessary yet. This one's also an integration skill. Uh, 2014 was a beautiful one. I don't like using these. One thing I'd encourage everyone who's here to do. I want you to have a go at question 14. I want you to have a go at question 10 here. Yeah? And you know, if you found me on Discord, you can send me a message and say to yourself, well, decent. I got a solution. This is my solution. And I'll ask you to explain it to me. And if I believe your explanation's valid, I'll give you full marks for it. But if I believe there's something missing from it, it's not fully explained, I'll ask why. If you can't answer that why, I'll say you didn't understand it. Or you looked at the solutions. The solutions of these are very easy to find. So, I'll be interested how people go with this question. I'm going to have a go at finding another nice one to do. Because there's a whole bunch of exam companies. I feel like exam companies are some of the most, like, underutilized thing. Because they, again, like, sure, you can say, oh, they're not going to be real VCAR exams. Yeah, they're not. The point is they're not going to be real VCAR exams. Yeah? But if all we care about is what the real VCAR exams look like, well, you might as well do nothing. Because nothing's going to be like your real VCAR exam. Yeah? You want to simulate it. Yeah? And to simulate it, you do the hard stuff so that the hard stuff looks easy. So, most of these, like, I would say there's a hard question in this iTude exam. Now, if anyone here is watching, and you know the iTude company, yeah, you'll know that the iTude company doesn't publish exams. But they used to. So here, if I have this question, right? There's no one watching it. That's okay. Because we're going to keep going. Let me just have a look. See if anything is going on. I have to go in about 20 minutes, but that's okay. So, here we have this determine the maximal domain. This function. Now it's a composite function. And for composite functions, we draw out this table. Do the domain. We have the range. We have here our inside function, which is going to be this. And we have our outside function, which is going to be this. That's our outside function. Now, here, what does this function look like? It's going to look something like this. You should know this from your learning of power functions. Many schools don't cover power functions. And I will say they don't cover it because it doesn't tend to come up. And it's very easy to skip a topic because teaching it is very hard. But we see that the domain of this one is going to be from 0 to infinity. Yeah? Here we'll have a look at this one. The range of this function. Right? If we see that there's going to be here, we have x equals 1. It's going to look like this. Because it's been reflected and has an asymptote here. Yeah? So, its domain is going to be all real numbers. But for this to be a subset of this, it must be between 0 and infinity. Now, if one day you want me to explain composite functions, because this may not make sense to many people. I know composite functions is a unit that a lot of the states struggle with. And it's because it's very poorly taught. You know, people always go on about the number machine and all this other stuff. But it's very poorly taught. Yeah? So here, right? When we see this, well, we see that this is going to be the range of this function. So here, it's going to be from 0. It's going to go all the way up to infinity. Yeah? Well, when it's going to be equal to 0? So we do 0 equals a half take away ln of x take away 1 over 2. And we get here a half ln of x take away 1 over 2, yeah? Which is just equal to e to a half x take away 1 over 2, which means we get 2e to the half plus 1 equals x. That's what we get as our final answer. Now, how did I do the algebra that quickly? You don't need to do that quickly. I'm not saying you have to, yeah? But we see this value, and we see here that, well, is it that? Yep, okay. So that means we see here that we get a domain for this function of 1, because that's an asymptote at 1, yeah? 2 e to the half plus 1, inclusive, because it can hit this point. Again, I'm using my graph. I'm using the graph. And this is a process you should be taught. If you're not taught it, give me a message. And I'll make a video, I'll make a live stream just dedicated to explaining composite functions. Because again, I think it's very poorly taught. And that doesn't mean that, you know, your teachers sucks at their job. They might suck at their job. That's not my job to tell them if they suck on it, yeah? But it means that here, well, that's a place that I can help you. And here, I'm here to just support students. I don't earn anything out of these live streams. I don't get anything. I'm not monetized. So I just do this for the pure enjoyment of doing this, yeah? So give me a message. Tell me if you want me to make a live stream about it. If you do, it's wonderful. I'll make the live stream. If you don't, that's fine. I won't make the live stream. But does that make sense? Does anyone have any questions, any comments, any concerns about what I just explained there? Any ideas about what happened, what I did? Anything you need to confirm with me? If there's anything at all, I'll explain it. So, I'm just checking something. I'm just making sure that, because I've switched to an internet provider. I need to actually connect to the NBN. I'm gonna try solve that question from 2014. Yeah, go for it. Give me a message. I'm guessing you're on my Discord. I probably need to change the name of that Discord. Because it's always on invisible. But give me a message after you get the solution, and I'll tell you if you're right or wrong. I'll hop in a call with you and I'll be like, yo, you got this right, or yo, you got this wrong, and I'll explain why. Yeah. Or if you can explain it, then I'd like to hear your explanation. Now, is there anything else I need to say? I would say most of the methods exams are very easy. Or you should be able to treat, if you want to get, again, between those higher scores, between those 45s to 50s, I would say the majority of these questions have to be easy for you. It's very hard to get a very high score if the majority of the questions aren't easy for you. Like here, I'll try. I won't have tried anything. I want to get some thoughts from everyone at home. Is there anything you'd like me to talk about or discuss or say? Is there anything that's itching your head that you think may need a discussion? I just have like some jazz music in the background, some copyright. I think it's copyright free. If it's not, I'm just gonna get cooked by the copyright system in the second watch. Be very interested how you go with that question 14. It's a very interesting question. I'm interested what most people's schools tend to do. I'd like to get like some more ideas about what most schools tend to do with these. Because what I've seen is that they do a whole bunch of random stuff with it, and it's very weird what they do. But teach their own again. Schools do weird things. They're always going to do weird things. I'm not going to judge them for doing those weird things. Because again, I don't run the school. I'm not their boss. I don't get to tell them what to do. With the last bit of time, what I'm going to do is I'm going to speed run this exam. And I want you to watch what I do. Yeah? The working out doesn't have to be strenuous. But I'll show you what I'll do here. Yeah? I'm going to try and do as many questions in 10 minutes. Because after that I have to leave. So let's have a go. So here. The working out line here is going to be this. Right? Once I have this working out line, I can use the product rule. Right? This is going to be the product rule. And I get here dv dx equals 2, dv over dx equals 1 over x, which means we get here 2, because it's 2x times x, plus 2 ln of x, yeah? Over here, right, I get u equals 10 of x, I get v equals 3x, and I get du over dx equals 1 over cos squared x. Yeah, I get dv on dx equal to 3. Yeah, f dash of x then must equal 3x over cos squared of x, take away 3 tan of x over 9x squared. So if we do here f dash of x, right, or f dash of pi over 3, we'll get here, well, here we get pi at the top here because it's 3 times pi over 3, over cos, I'm just going to do a side here, cos of pi over 3, that's just 1/2, so that means here 1 over, so that means here we get cos squared, which is going to be 1 over 4, take away 3, pi over 3 times that by root 3, over 9 times by pi over 3 squared. These two are going to cancel out with one another, and we're going to be left with 4 pi take 3 root 3 over pi squared. So do you see that? I'm using my mental maths. And here, how did I do that? I had tricks set up. I had tricks that I'd built up over my time through exposure. So here, if I do this g of x, it's the integral of 3 2x over x dx. Yeah? Right? Here we get 3x take away 2 ln of x plus c. And we know that g of 1 equals 2, which means 2 equals 3 take away 2 ln of 1 plus c, which means c equals -1. So we get g of x is equal to 3x take away ln of x take 1. Right? Here, this graph. I'm using, again, a little trick that I built up. The point here is going to be -2 comma -1. So we get here -2 comma -1. So we have here -2 comma -1. Right? That, and then here we substitute in, well, when does this equal 0? We get square root of x plus 2 take away 1. We get 1 equals the square root of x plus 2, which means that here we get 1 x plus 2, which means x equals -1. That's where this intercept is going to be. So we get here, oh, it's because I put it too low, that's fine. For a second, it's just like gone. And then if I plug in 0, so f of 0, we get here square root of 2 take away 1, which is approximately going to be between these two. It's going to be something like this. So here we get -1 comma 0, and here we get 0 comma square root of 2 plus 1. Oh wait, take 1. So we get given this shape. Did you see how simple I've made this? The average rate of change of this function, well, it's just going to be f of 2. Take f of -1 over 2 take away 1. That's what the average rate of change formula is, right? So here we had a square root 4, square root 4, square root 4, take away 1, take brackets. Here we had -1. Oh wait, -1 was just 0 over 1, which means we get here 2 take away 1, which is just 1. That's the average rate of change. So how did I get that 0? I'm using tricks from up here that I've used. Yeah. Down here, this 15. Oh, I'm gonna skip this one because it's a probability question. Oh, this is also a probability question. I don't want to look at the probability questions yet because the schools don't have tended not to start these. Here for this question, find an expression in terms of in terms of x for L. In terms of wait, what? Shown here, it's concepts here. P equals x. Point P lies on the graph here. Point Q lies on the graph here. Vertical distance. We need to find the distance between these two line segments. Yeah. And they're vertically above, which means they're just vertically distance. So here it's just going to be g of x. So because we want to find because they're vertical distance, and we want to find the length of this, right? It means here that L is going to be equal to g of x take away f of x. Now here, technically, this is in terms of x, but just for security, I'm going to put in, right? I'm going to put in these actual values. So we get here 5 take away x, take 1 over. Oh wait, pretty sure it's 4. Yeah, it's 4. 4 over x. Does that make sense? Right? We find the minimum distance. So we do d on dx equals, what's the derivative of this function? We get here -1 plus 4 over x squared, which means here if we let this equal 0, so d on dx, we get here 0, so we get 0 equals -1 plus 4 over x squared, which means here if we do here 1 equals 4 over x squared, which means x squared equals 4, which means x equals plus or minus 2. But again, I get if I get a plus or minus solution, I'm always going to check my domain. And I realize that x equals 2 because x is greater than 0. Does that make sense? So, here, the tangent to the graph of f at the point where x equals 2 makes an angle of theta with the positive branch of the x-axis, right? So here, the tangent at x equals 2 makes an angle, the positive branch of the x-axis. So here, we're going to use our formula, right? We're going to use another formula. We're going to use the formula m equals tan theta, right? And we can find out what m is because m is just the gradient at this point. So let's just find out, well, what is f dash of x, yeah? F dash of x is just going to be, f dash of x is just going to be -4x squared, right? So then if we do f dash of 2, we're going to get -1. Which means here, this is also -1, yeah? So we get here tan of theta. And we want to find the angle that makes the positive x-axis. So here, right, if this is our angle, right, we want to find out what angle it makes with the positive x-axis. The positive x-axis, right? So here, we'll get theta equals 135 degrees. Is that all good? Here, I have this question, right? This is an enclosed area one. We won't worry about this one either. But does that make sense? Is there any questions about that? I just spent that time going through a bunch of these questions. And I want to see, what does everyone think? Should I keep doing these live streams? Should I keep doing these live streams for your entertainment? Should I keep doing these live streams for educational purposes? Tell me all. Tell me all of this in the comments. I'd like to hear more about it. Tell me more of your ideas. I'd be interested in what you have to say. And how I can apply this onto my own teaching. So, I will see you all. Bro, you should do live streams for specific topics like differentiation. I was considering doing that. Instead of doing poll exams. That's true. I did consider doing that. It's just that I wanted to get enough people to do that. So I wanted to see if I can get enough people to do it, like, all together. Yeah. But I would actually, I'll do that. I want to do it on composite functions. That's the first thing that I want to try on. And based on that composite function one, I want to see how it goes. How people think of the composite functions. So expect next live stream to be based on composites. And inverses. And a little bit of sketching. Because I'm going to say this now. Diff, all of calculus, incredibly overhyped. They're very useful, but they're not useful without these other skills. Mainly with sketching. The composite functions, they sort of work in their own domain. Is there anything else you recommend I do? Any other suggestions? I'll try and get some more people. I want to try and get some more people in here, just because I want to. One thing I've always never liked is that I never like the big tutoring companies where they have, like, you know, they charge you, like, you know, $200 for, like, I don't know, your liver or some like, they charge you your liver for, you know, to do tutoring with them. I don't really like that. I sort of want to step away from that. So that's why I want to do more of these live streams. So. No, okay, thank God. No one's scratching my window. I'll do a live stream based on composite. Okay. So, I'm gonna end the stream off here. And I'll catch you when I do. See you later. Goodbye. For now.